The question is, could you do an example on adding 3D forces by the algebraic method? This is my second example on the topic, and here I will focus on the application of the direction angle method. This is the problem that I have selected here. We have two forces, F1 and F2, acting at point O, and we need to find the resultant of these two forces. The magnitudes are given for both F1 and F2, but for F1, the direction angles are given in order to define its direction. For F2, the projection angles are given. Remember what we do when the direction angles are given for a force, right? We take the magnitude of the force and multiply that by the unit vector, right? The unit vector is cosine of the angle that F makes with the x-axis multiplied by I, plus cosine of the angle that F makes with the y-axis multiplied by j, plus cosine of the angle that F makes with the z-axis multiplied by k. The magnitude of F1, of course, is 200 pounds. So let's keep the unit as well. Simplifying it, we get this for F1. The projection angles are given for F2, and therefore the procedure there is identical to what we did in the earlier example. First, we take the right triangle ABO and recognize that AO is the hypotenuse of that, and this angle here is 30 degrees. So 160 sine 30 gives me this distance, A to B, which is the y component of that force. So that goes in here. We also know that the arrow on that side is in the positive y direction, and therefore that goes in as a positive term. The length of this side, O to B, is 160 cosine 30. And we're going to take that and resolve that along x and z direction in order to find the x component and the z component. So you see 160 cosine 30 going in on the first term and the third term. Now we take this right triangle OBC and note that OB cosine 40 is going to give me an x component, but it's in the negative direction. So we put a negative sign in front of that, and this term is being multiplied by cosine 40, and then the sine 40 of OB is going to give me the z component. So you see sine 40 here, and that too has a negative sign with that. Simplifying it, we get this. Here is the resultant of the two forces. The magnitude of the resultant is obtained by this equation. So we get a value of 255.5 pounds for that. The direction angles are given by these equations. So we get 91.4 degrees for alpha, 12.34 degrees for beta, 102.3 degrees for gamma. So these are the angles that the resultant F makes with the x, y, and z axes respectively. As an additional check, you could calculate this quantity, cosine squared alpha plus cosine squared beta plus cosine squared gamma, and that should work out to be 1. Because remember, this is the magnitude of the unit vector, right? So unit vector has a magnitude of 1.